Alright, hello guys, welcome back to Mathematics Tutorials. Today we have a video about slope fields. So what is a slope field? A slope field is a sort of visualizer for a solution for a differential equation. So what's a differential equation? A differential equation is basically any sort of equation that has, a function and the derivative of that function in it. So look at something like this, right? dy dx equals x over 5, right? So we're basically saying the um, derivative of y, the change in slope of y equals x over 5, right? So we could also kind of write this as, oh, I'm in the wrong color, y prime equals x over 5. So now, one way we could solve this is to integrate um, both sides, right? Because then this would be y, this would be what? Uh, x squared over 10 plus c, right? Um, and that works, right? But it's not always going to be so easy to find a solution like that. So sometimes you're going to want to visualize it like this. And by the way, something to note is that if you look at this right here, it's x squared over 10 plus c. If you start anywhere here and you follow the lines that it forms, you kind of get a parabola, which happens to be in the form of x squared divided by 10 plus c, right? So obviously, depending on where you start, it's going to be in a different place. But if you just go up and down, that's basically the same as just changing that constant. So there's that connection there. But to get each point here, what you do, let's say I wanted to get the point at 5 comma 5, right? What I would do is say, okay, y is 5, x is 5, right? And I'm trying to find this dy dx. So I use this equation right here. Now, one thing to note about this is that this only has x in it. This could have x, y, like x and y in it. So you could say like x plus y divided by 5, x times y divided by 5, x over 5y, something like that. But this only has x. So which means you take the x value, which is 5, and divide it by 5 to get 1. So the slope at 5 comma 5 should be 1, which it looks like it is, right? Now because it doesn't have y in it, that means the only thing that changes it is x, which means if you go horizontally, it changes, right? So look, this is different than this slightly, but they're much different than, this one or this one over here. But if you go vertically, they don't change at all because the only thing changing is the y, and we already established that the y doesn't matter. So like that's the same as this, right? So that's for this, pretty basic. Now what if we go to one down here, like we said, dy dx equals y, or x over y. So this could look, you could also see this written as y prime equals x y, or even, y prime y equals x, something like that, right? But this one, right, a little bit more complicated. It wouldn't be immediately obvious how to integrate it like you would with this one. But if you have a slope field, right, which is pretty easy, right? Because if you have this equation, even if you don't know the actual function y, um, you can still make a slope field. Because what you can do is just say, I'm just going to say x is 5 and y is 5, right? Or I'm going to say x is 3 and y is 2, right? And just plug it into the equation and you get the slope, right? So for something like this, again, you could say, well, I don't know really what it is, but a solution could look like, this. Oh, let me do this. The solution, the actual, y, function y could look like that, or maybe something like this, right? Maybe something like that. Oh, maybe something like this, right? And actually, I'll show you the um, actual solution. So this is just for one constant c, because of course, when you integrate, you're going to have a constant. That's going to change a lot of things. But this is what it kind of looks like. So you can see, right? Let me put it right there. It kind of makes sense. It follows the same general shape, right? Because it looks like, it kind of goes down towards the middle, right? Down towards the middle and then back up. Same thing you can kind of see here. So this looks like it goes down to about here. So it'll go down about there and back up, right? And then it seems like it's also actually reflected on the other side. So this can kind of give you a rough idea um, of, you know, what all the different slopes are going to look like for differential equations. So let's actually make a slope field out of scratch, right? So I have this right here, this differential equation. So y prime plus y to the third minus y equals x. So obviously, look at this and you're like, what the heck? I have no idea what, the function y is going to look like. Um, but that's what the slope fields are for. So let's see. So let's try to get y prime by itself. That should be the goal, right? Because y prime, remember y prime is just another way of writing dy dx. I think there was some like disagreement about that at the beginning of calculus. I don't know, but you can use both. So when I say dy dx, that's basically this y prime. And we're going to try to isolate that like we have right here and right here. Now, of course, this is just algebra. So first I'm going to, factor out the y prime. Remember, this is a y prime. This is y prime. This is an actual y with an exponent. I know they kind of look similar, but it'd be like that sometimes. So like that, and then of course y prime plus y squared minus 1 equals x over y. And then let's just get y prime by itself. Y prime equals x over y plus 1 minus y squared. Okay, so now let's make our own thing. So let's rewrite that up here. Dy dx equals x over y plus 1 minus y squared. Okay, so now this is a Cartesian plane. I didn't label it, but this is 0, this is 5, -5, etc. It all just goes by ones. That's also not exact because I pretty much just sketched this. But let's see, what would you do? What I would do is start at 0, 0, and I would plug in 0 for x and 0 for y. So 0 divided by 0 plus, yeah, I don't know how that works. I'm going to be honest with you. So I'm just going to leave that blank, and that is going to happen sometimes. Like, for example, uh, for this one, if y is 0, like it is along this whole axis right here, right? This whole thing y is 0, and you can see they didn't put any lines because it's undefined. And that's okay. That'll happen sometimes. So same thing here. Since we have a y in the denominator, the whole x-axis basically is going to be undefined. But that's not a problem. It's just that happens sometimes. So let's see. What about 0, comma 1, right? So if y is 1 and x is 0, so that'd be 0 plus 1 minus 1 squared. So that'd be 0. So right here, the slope should be 0, right? So I'm gonna do this in red, um, because why not? So right here, slope 0. Okay. So now, what about if we keep x is 0 but y is now 2, right? So that would still be 0 plus 1 minus y squared, right? So that would be what? Minus 4, so that'd be -3. Oh, so now that would be -3, right? So that obviously decreased pretty quickly. And it seems like as y gets higher, this is just going to get more and more negative because this is going to be 0 and then 1 minus y squared. So this is basically just going to get more and more negative. And it's almost going to look like kind of a straight line, but it's not quite. Now on the opposite side, it's going to do, well, what is it going to do? It's basically going to be the exact same, right? Because it's not going to be affected by this because the x is still 0 on this axis. The 1 doesn't change, and then the y squared doesn't change either because once you square it, being negative doesn't matter. So it's going to be 0, and then -3, and then more and more negative. I can calculate the exact values, but you get it. Now, what about, let's say, 1 comma 1, right? So that would be 1 plus 1, so 2 minus y squared, which is 1. So that means the slope right here is going to be 1. I should probably just use the line tool. So that's about 1. Now what about right here at 1, 2, 3, 3 comma 3. So that'd be 1 plus 1, so 2 minus 9, so that'd be -7. So at 3 comma 3, it's very negative. And so you see how you can kind of start filling in, right? This one actually changes, pretty quickly because of this negative y squared. So even like right here, it's going to be pretty negative. Um, not quite as negative, but and then obviously it's more and more negative. So you can kind of see how these things can change pretty quickly. But in general, if you look at this whole line of x or of y equals 1, it's 0 and then 1 and then not quite as steep and then or steep a little bit steeper and steeper and steeper, right? Kind of goes like this. And I'll show you what the what the actual thing looks like to give you an idea, kind of. Um, so this is what the slope field looks like from -10 to +10, right? So you see we had the zeros there, the ones there, and then kind of changes as you go. And like I said, this one, because of the negative y squared, it gets steep very quickly. Um, Now, what if we want to figure out what y actually looked like, right? Well, what we would basically do is kind of just pick a point and then follow it, and then that would be a solution, right? So it looks like, it's not always easy to follow these things because you kind of go in increments of one. By the way, you can go in increments of whatever. It's just that it's hard, you can't really show it that easily if you do like literally every single point, so you kind of have to choose some sort of arbitrary increment. But like if you start here, right, it seems like you would go basically straight down, and then at some point you would kind of do one of these maybe, and then go back up or something like that. Or maybe you would hit an equal. Well, it seems like it's going up here and down here, right? Like if you look at the slopes, these white ones are positive and these red ones are negative. So it seems like if you go um, to the white level, you would go up, but if you go red, you would go down. So I think it's gonna kind of level off somewhere in there, right? So you would, down and then maybe something like this, something like that, maybe. Not entirely sure, um, but that's okay. All right, so yeah, that's slope fields. Very good for visualizing if you ever have to solve a differential equation, especially if it's not something trivial. But yeah, so I guess that'll be all for today. Let me see, what should we go over next time? Hopefully this was useful. This is a very basic kind of video, even more than the other ones. But you need that sometimes. It's already like 10 minutes, so whatever. I'm sure you guys aren't like, super distraught about it. Um, Bro, where is the table of contents in this textbook? Oh, I missed it completely. All right, so that was slope fields. More differential equation stuff. I kind of touched on in this. Let me see if there's anything in this book that is like vastly different from what I kind of touched on today. Um, and if I feel like covering it, which I might not. Homogeneous differential equations, whatever that means. Should we even do this stuff? Probably. Let's see. First order differential equations. Interesting. Bernoulli. Dude, I'm gonna be honest, I don't even remember this stuff. Um, Next time we will do. How about this? We're gonna go back to integration. So next, okay, I'm still in the white color. There we go. Next, what? How'd that not work? Oh, there we go. Next time, um, area of a region between two curves. So that'll look like something like this, right? You have, let's say, like a sine type thing, and then you have like a parabola, right? And you want to find this area. So we'll look at that next time. All right, and I guess that'll do it. So goodbye.